Dear students, welcome to another lecture in quality control. Today, let us see about Six Sigma. Yesterday, we have seen about TQM, Total Quality Management, and today's topic is Six Sigma. Now, Six Sigma means Six Sigma. Sigma, you in mathematics and statistics, you have seen sigma is used for standard deviation. So Six Sigma means 6 standard deviations. So today let us see what it is. Six Sigma is the management technique of reducing the variations in all critical processes to reduce the number of defectives produced at the end. You see, the aim is to reduce the defective parts. You see, in total quality management also, we said the aim is to produce zero defects. Now in Six Sigma also what we are saying is the aim is to reduce the number of defective products. That means almost to make it zero. Okay, how we are trying to do it? We want to do it by reducing the variations in the processes, in all the critical processes or the processes from where these defectives arise. In such processes we want to reduce the variations. The variations by reducing variations means when we give specifications, so the specifications and according to the design specifications, our machined components should conform. So when this conformation is when we are checking, the variation should not be much. That is what we are trying to reduce in Six Sigma. So Six Sigma technique is applied to reduce variations existing within 6 standard deviations plus or minus of the process selected and adopted or followed to produce non-defective products. So this is one definition. Okay, see what the moment Six Sigma comes into picture, you should tell this phrase, it is applied to reduce the variations and reduce the variations within 6 sigma deviations, 6 standard deviations. Okay, reduce the variations in the processes so that the products produced are non-defective. Okay, now there are many similarities between Six Sigma and total quality management. Now what are the similarities? First let us see, and afterwards we can see the differences between Six Sigma and TQM. Okay, now like TQM, Six Sigma also is aims at, it has the philosophy of reducing the defective parts. Both TQM, Six Sigma, they are used for reducing the defective parts. Then like TQM, Six Sigma also has a direct link with profitability achieved by saving the cost of rejections, cost of rework, cost of repairs, cost of processing the consumer complaints. See, when the defects are coming to zero or drastically reduced, then all these expenditure that we incur because of the rejections, because of the rework, because of the repairs on that on the rejected parts, and because of the cost of because of the processing of the consumer complaints, whatever costs are coming, these can be reduced, and thereby the profitability increases. Okay, now third, in fact, Six Sigma techniques contribute in achieving the goals desired by TQM techniques. You see what goals you are having in TQM? In Six Sigma also we are having those goals, and we are aiming at those goals and only more effectively and to improve the process control. Now Six Sigma technique is applied to reduce the variations found amongst the products manufactured at the same time, leading to defective products. You see, again and again this phrase is coming: reducing the variations in the process, reducing the variations of the process. So when you talk about a Six Sigma technique, you should use this word. It is aimed at reducing the variations in the process so that defectives are zero. Defectives come to almost zero. Defectives are drastically reduced. You can say like that. And now Six Sigma is a rigid technique to implement and allows very small variations to lie within the Six Sigma deviations, either plus or minus, and to reduce the quantity of defective products. Yeah, this is another definition. You see, here they are saying it is a rigid to implement. You see, rigid to implement means there is no leniency. There is not much flexibility given. You see, you have to maintain the process in such a way that these deviations they fall within Six Sigma. Okay, like that. Now next, let us see the differences between Six Sigma and TQM. You see, both these techniques, Six Sigma and TQM, both are effective tools in the hands of the management for maintaining the quality, but a thin line of difference exists. So the difference is not much, but it's only a thin line. Okay, now let us see what is that's why unless you come very closely and see, you won't find the difference. It will from the far it looks like both are same, something like that. That's why we are saying it's a thin line of difference exists. Okay, now Six Sigma, first difference: no compromise or flexibility in carrying out quality activities is allowed in Six Sigma techniques. See, just now we said it is a very rigid technique. Okay, due to this rigidness, tougher and harder targets of quality can be achieved. Okay, and what are they saying about TQM? Use of TQM tools cannot achieve tougher and harder targets for quality. So it is not as rigid as Six Sigma. So it cannot achieve tougher and harder targets of quality, they say. The second one is Six Sigma is a new and modified concept than TQM. So TQM came earlier, Six Sigma came later. So it is a new one, and it is taken from the other things, and it has evolved. Therefore, it is a modified concept than TQM. So naturally, you can say TQM being a little concept that has evolved earlier, and Six Sigma being new. This has certain advantages over TQM. Even though Six Sigma and TQM have certain similarities, Six Sigma cannot be used as exact replacement of TQM, because some of the techniques, methodologies that we are using for Six Sigma are not present in TQM. So Six Sigma, though there are similarities, it is not the same. TQM was the second difference in TQM is the TQM's tools were established before the evolution of Six Sigma techniques. That's what we are saying. It is an older one. Okay, third one: Six Sigma concentrates on making small changes in the processes and systems to ensure high quality. See, this is what is concentrating on: the process capabilities, the changes being made to process and systems. That is what Six Sigma is concentrating. You see, if suppose you want to produce a shaft of 50 mm diameter, but because your machine is not good, or because your workers are not so efficient or so skillful, instead of producing 50 mm diameter, you may produce a little larger diameter or a little smaller diameter, above 50 or below 50. You see, exactly very close to 50 you may not be able to produce. Okay, but now Six Sigma is concentrating on making changes to processes and systems, and thereby ensuring high quality, whereas TQM concentrates on maintaining the existing quality standards and improving the quality. And the fourth difference is applying Six Sigma is a complicated process. Complicated in the sense it needs special training about the implementation procedure of Six Sigma to be given to employees of the organization. So special training and other things are to be imparted to the people. And whereas TQM is less complex to implement, it doesn't require any specific training to be given to employees of the organization. Okay, now fifth one is Six Sigma is a result oriented approach, giving much better and effective results as compared to TQM. Whereas TQM gives lesser rejections and tries to reduce the cost of wastage, scrap, etc. by maintaining existing quality standards. So here, TQM tries to reduce the cost by avoiding wastage, scrap, etc. Okay, and then now let us see Six Sigma and with explanations. Okay, Six Sigma stands for 6 standard deviations from the mean. And now mean means, if you say X bar is the mean, from that, here sigma is the Greek letter used to represent standard deviation in statistics. Six Sigma is defined as, here another definition is given. It is a disciplined and a systematic data driven approach for eliminating defects in any process, whether it be manufacturing company or service company. Okay, then Six Sigma methodology provides the techniques and tools to improve the capability of the process. So here now Six Sigma, what it is aiming at is improving the capability of the process and thereby reducing the number of defective products. So Six Sigma is providing the techniques, tools to improve the capability of the process. Okay. Six Sigma technique is used to reduce variation in all critical processes to achieve continuous improvement, which benefits the organization and increases the customer satisfaction. So it benefits the organization also, thereby if the defective parts are less, the scrap produced is less, and everything is, so much cost you are avoiding, and it increases the consumer satisfaction because your product should be of high quality. The number of manufacturing and service industries are using Six Sigma techniques, and they have found it very useful. Many people proudly display that their company is Six Sigma compliant. Okay, then objectives of applying Six Sigma projects is to implement a measurement based strategy. You see, it is a measurement based strategy which concentrates on process improvement and reductions in variations amongst the products. You see, measurement based strategy. See here, when you say standard deviation, that means what? There is a measurement always involved. How will you know? See, this is 50 mm diameter of the shaft. This is what is according to the design specification. Now, how much from that is the diameter that you have manufactured? Is it a little more? Is it a little less? If you take number of such readings, you will know how much deviation, how far these values are coming. Okay, depending upon that you get a standard deviation. Okay, see that standard deviation, that standard deviations of the of those measurements, it should be very close. Then only it will be complying to Six Sigma. Okay, that's why we are saying here it is a measurement based strategy. Okay, this is another phrase you can keep in mind when you are talking about Six Sigma. One thing is, we have said reducing the variations of the process, and another thing you're talking about measurement based strategy. Okay, these things you can keep in mind when you're talking about Six Sigma. Okay, here what they are saying is, in other words, Six Sigma is a management technique designed to create manufacturing services, etc., which reduce defectives and maintains cycle time. Okay, then Six Sigma refers to a goal of achieving zero defects. Now this goal of achieving zero defects we found in TQM. Okay, see, Six Sigma refers to a goal of achieving zero defects by using statistical quality control methods. Its approach is based on concept of normal distribution. Now you may have learned in statistics normal distribution curve. Okay, now this methodology of Six Sigma, it is based on normal distribution curve. Okay, we will see about this curve and everything. Okay, now Six Sigma is also defined as a vision of quality which allows only 3.4 defects per million opportunities. See, this 3.4 is important. Say defects per million opportunities, DPMO. DPMO means defects per million opportunities. How much is a million? So in India we find it difficult to understand sometimes what is million. In our language, to easily understand the million is, it is, if you say in lakhs, you will know it is 10 lakhs. Million means 10 lakhs. That means after 1, if you put 6 zeros, it becomes 1 million. Okay, 10 lakhs. So in 10 lakh products if you produce, say at the maximum how many defective parts can be there? 3.4 defective parts only can be there. Okay, so to striving for perfection and to achieving this type of high quality, you see, we are not talking about 3.4 in every 100 pieces, or if we are not talking about 3.4 in every 1,000, or we are not talking about 3.4 in every 10,000. We are not even talking about 3.4 in every lakh. We are talking about 3.4 defective parts in every 10,000 products that we produce. If defectives are there, such a kind of quality vision is Six Sigma. Okay, in other words, 99.99966% of the total products produced will be non-defectives. You people proudly say, I got 92% marks, I got 94% marks, 96% marks. Nowadays, because of multiple choice questions and options that you are having, you are able to get high percentages. But 99.999, 3 times 9 on the after the decimal, 66%. Such so much of total products produced to be non-defectives, how difficult it is, how your process should be so capable. You should understand here. See, now what is this 3.4? 3.4 means out of 10 lakhs, 9 lakhs 99,000 996 parts are non-defectives. Only 3.4 are defectives. That is the meaning. Thus, Six Sigma improves the process performance and reduces the variations and maintains continuous quality of the process output. Okay, this results in defect reduction and improvement in profits, product quality, and customer satisfaction. Now customer satisfaction is the goal for all the quality methodologies. Okay, and now customer will be satisfied when the product quality is good. Okay, and your profits will improve when customer is satisfied and is willing to spend the money, and also when you are able to produce for a lesser cost by not producing the defective parts. See, these are all there. Okay, then Six Sigma is mainly focused on output of process. It tries to achieve minimum level of defectives produced by maintaining the process within the range of Six Sigma, plus or minus Six Sigma. Plus or minus we are saying because if mean is there, X bar in the middle, on left hand side minus sigma, on right hand side minus sigma. Okay. Now here let us see an example. For any variable quality characteristics, when number of observations are plotted, number of observation, for example here the measured value of diameters of shafts that you have produced in your company. See, if these diameters are plotted in the form of frequency polygon, then the frequency polygon shows a smooth curve obtained by joining various dots on the graph. This graph is normal distribution. Now I'll show you a figure here. Now this is the normal distribution curve. You see, in the center you have X bar. This is the mean. On positive side, if you see 1 sigma, 2 sigma, 3 sigma, 4 sigma, 5 sigma, 6 sigma. On left hand side you see minus 1 sigma, minus 2 sigma, minus 3 sigma, minus 4 sigma, minus 5 sigma, minus 6 sigma. You see, if you are saying 6 sigma plus or minus 6 sigma means, from here to here, this is the range that we are talking about. And this curve, is that we got is called the normal distribution curve. And here you can see at minus 3 sigma and plus 3 sigma, you have these specification limits, lower specification limit and upper specification limit. See, the upper specification limit, sometimes it is called as USL, and lower specification limit is called LSL. This upper specification limit means, see, suppose our diameter is 50 plus or minus 0.02 mm. That means upper specification limit will be 50.0 50.02 mm is the upper specification, and lower specification will be 49.98 mm. So that is the lower specification. Okay, so suppose if you are taking 1 sigma, then 30.23%, these many only will be non-defectives, the others will be defectives. If you take 2 sigma, 69.13 will be non-defectives, and others around 30% are defectives. Then if you take plus 3 minus 3 sigma, then 93.32% are non-defectives, but still around 7% are defectives. If you take 4 sigma, 99.379 are non-defectives, and defectives are less than 1 only. But you say, okay, this is also good quality. Why can't you stop with 4 sigma? Why you have to go up to 6 sigma? See, the more stringent specifications if you give, the more good your equipment should be. More equipment should be of such a high standard means it will cost more. Then why 99.379%, this 4 plus or minus 4 sigma is giving? Why can't you be happy with that, you will say? But See, they are aiming at not 99.39 as in 4 sigma, not 99.9767% as in 5 sigma, but as in 6 sigma 99.99966%. So this is what they are aiming at. See, if you say okay, in 100 not even one is rejected. Now if you say about 6 sigma, not in 100 one, not 1 in 1000, not in 1 in 10,000, not 1 in 1 lakh, 1 in around 3 lakhs or something. That means on the whole in 10 lakhs only 3 pieces are rejected. You see, that is the high quality that is a 6 sigma aims at. Okay. Now, after applying 6 sigma techniques, we find that maximum outputs of the process will meet the specification. Maximum outputs will meet the specification. The specification is the mean X bar, but some will deviate to a varying extent. You see, everybody cannot produce 50. Even a very highly skilled person cannot produce every time 50 diameter shafts. See, there is going to be variations, and these variations are measured by the standard deviation sigma. So therefore, some units will have a specification X bar plus or minus 1 sigma. Some units will have 2 sigma variation, some will have 3 sigma variations, some will have 4 sigma variations, and other few units will have specifications of 5 sigma or 6 sigma. The chance of a part falling outside 3 sigma control limits is 66,800 parts per million. You see, here, the 3 sigma here, 93.32%. Okay, so if you are using for 3 sigma this 93.32, that means almost 6.68% are falling, are not satisfying. Okay, so that means what, totally when you take for a million, then this becomes a huge number as 66,800 parts are defectives. Okay, whereas if you take about if you talk about 6 sigma, if you are using 6 sigma control limits, then per million defectives will be only 3.4. okay, so much is the variation between 3 sigma and 6 sigma. Okay, that means what, the probability of the parts produced falling outside the control limits is much higher in 3 sigma control limits as compared to 6 sigma. Due to this reason, 3 sigma quality level cannot be accepted as good enough quality level, but 6 sigma is preferred. Therefore, 6 sigma is nothing but extension of the control limits from plus or minus 3 sigma. Maybe in the olden days they were satisfied with plus or minus 3 sigma. Now you have to bring it to plus or minus 6 sigma limits. Okay, now we are talking about process capability. What is process capability? This can be defined as the upper specification limit, that which is called USL, and if you subtract it from it, the lower specification limit, then this is the process capability, and this process capability should be maintained as 6 sigma. That means what? You see, if upper specification limit is 50.02 mm and lower specification limit is 49.98 mm. So what is the process capability? 0.04 mm. So that is the the maximum variation in the process. So if all your products you are able to produce within these two specification limits, that defines your process capability. Our 6 sigma should be kept there. Okay, now Statistical approach of Six Sigma. Six Sigma technique refers to a goal of achieving zero defectives by using methods of statistical quality control. Approach of Six Sigma technique depends upon normal distribution. This table here shows sigma levels corresponding to percentage of total area under the curve, normal distribution curve, within the specified levels, specified limits. You see, it can be plus or minus 1 sigma limit, 2 sigma, 3 sigma limits, 4 sigma, 5 sigma, 6 sigma limits. So what is the percentage of products within the specified limits? What are the non-defectives or accepted parts? How many will be there? You see, in 1 sigma limits only 30.23%. In 3 sigma 93.32% will be within the non-defective parts, and in 6 sigma 99.99966%. You see, these values exactly you should be able to tell. It is better to keep all these values exactly to memory. It is better to memorize, because these things will be asked as even in interview questions, viva questions, and even in multiple choice questions. Nowadays your exams are being conducted by multiple choice questions. These may be asked. What are the 3 sigma percentage? What is the 6 sigma percentage? Sometimes even 4 sigma, 5 sigma can be asked. So this is the percentage of non-defectives. And what will be the defectives? Defectives are not given as percentage. Instead they are given as numbers here. Numbers per million. You see, DPMO, that is defects per million opportunities. You see, whereas for 6 sigma it is only 3.4, for 5 sigma 233, 4 sigma 6210, for 3 sigma it is 66,800, for 2 sigma it is 3,08,700, for 1 sigma it is 6,97,700. So many defectives will be there in every 10 lakh products that we produce. Okay. The same thing here we have shown in the text form as earlier we have shown in the table. See, let us assume that the total quality of products produced are 10 lakhs or 1 million. So in plus or minus 3 sigma limits, 93.32% are accepted products. And what is the rejected product? 6.68. So this works out in 10 lakhs 66,800. In 4 sigma limits, the accepted percentage is 99.379, rejected percentage is 0.621%, and this works out to 6,210 defective products in 10 lakhs. Whereas in 6 sigma, the acceptable range is 99.99966%, and defective percentage is 3.4 into 10 to the power minus 4 percentage, and this works out in 10 lakhs. This works out to 3.4 defective pieces. So the conclusion is, if we apply 6 sigma control limits to the process, then the number of defectives produced in 1 million is only 3.4. That means it is almost very close to zero. See, that means what? Almost in 3 lakh parts, one is being rejected. So that is almost very close to zero. Okay. Otherwise, as in this last line we are saying, 3,400 defectives will be there in 1 billion products. 1 billion products. Okay, this is called Six Sigma technique, achieving very less defectives. 1 billion when we are talking, how many zeros will be there after 1? 9 zeros will be there. Okay, for 9 zeros, that means for 1 billion 3,400 is very small. Okay, so this is how Six Sigma technique is trying to achieve very less defectives. Okay, now here an example is given. Let us take an example of time taken by the bus transport company from Pune to Mumbai on every day of the month for 30 days. So due to various factors, the time taken by the bus will differ on different days. See, and we note down the time taken by the bus to travel. Say, suppose say four times the bus reached at 160 minutes in within 160 minutes duration. In 5 times it reached in 170 minutes. 12 times it reached 180 minutes. 180 minutes means within 3 hours from Pune to Bombay you're gone. Okay. And 6 days you reached in 190 minutes. And 3 days you reached in 200 minutes. That means 3 hours 20 minutes. Okay. So if this is plotted, taking time in minutes on the x-axis and the number of times the bus is reaching on the y-axis, or the frequency on y-axis, now you can see 160 4 times, 170 5 times, 180 12 times, 190 6 times, and 200 3 times. And if you join this, you get a curve like this. This is more like a normal distribution curve, bell-shaped curve. So here, if this transport company is aiming to achieve, they should find out standard deviation, and they should try to maintain this. Now here for the transport company means, how the traveler or the customer will be happy if they say in 3 hours we will reach, you should reach in 3 hours. Those companies, they will highly rate if the bus is able to take them exactly in 3 hours. Okay, because some people will have important appointments. Okay, they don't want to waste their time. For some people, time is precious. Time is more. They cannot afford to lose the time. Okay, so anyway, see, if you can assure them that we follow Six Sigma methodology, and our deviation from the mean will be sticking to Six Sigma. Okay, then what it will achieve is it will achieve the customer's satisfaction, and it will earn goodwill for the company. So like that, this is only example for the bus, a travel bus, but it can be applied to any manufacturing process for any product also. Okay. Now Six Sigma certifications. Now Six Sigma certifications, they give certifications. That means the certificates they give. Six Sigma certifications, they confirm they are a they are a confirmation of an individual's capability with respect to specific competency. Now Six Sigma competence provides you, what it provides is, it provides you the ability to deliver the business benefits effectively. It gives you knowledge and skill to increase and improve efficiency of all processes and workflows. See, that means it will make you, if this certification if you have, it will make you knowledgeable, and it gives you it makes you skillful. Wow, why? To increase, to improve the efficiency of the process and workflows. See, as a person who is Six Sigma certified, you will be able to do the things efficiently, and you will be able to guide others also. Okay, then ideal preparation for a leadership role. It will make you a leader. And analytical, statistical, and project management skills, etc. These skills, analytical, skills, statistical skills, project management skills also, it will teach you, or it will make you skillful in these things. That's why, Six Sigma competencies you should get, and by achieving the Six Sigma certification. Six Sigma as a management methodology helped thousands of professionals and thousands of industries worldwide to reduce the cycle times. Okay, within the use of Six Sigma technique, various benefits like increased productivity, improved quality, improved process performance, etc., can be achieved easily. Six Sigma professionals exist at various levels, each level with a different role to play. See, now we'll see these levels. Now, the martial arts belt structure is used to recognize the proficiency in training and application of Six Sigma techniques. So there you're going to use colors like black belt, green belt, yellow belt, white belt. Okay, now let us see about these things. Okay, you see various levels of Six Sigma here. You can see 5 levels of Sigma. The first level, highest level, is certified as master black belt. Second is black belt. Third is green belt, yellow belt, white belt. As in karate, kung fu, and other things, you have belts, black belt in karate. Okay, like that, here also they are giving belts. Okay, so the master black belt, he will, this person is he trains black belts and green belts. Black belts, green belt means this second level, third level people. This first level person trains. That is one responsibility, the one thing that he does. And he acts as a full-time Six Sigma technologist. He is a full-time technologist. He need not be bound to any company or something. He can work as a consultant to many people. He can go to various companies, various cities, various places, and he can impart the training, and he can do work full time. He is not having any other responsibility. Only this as a Six Sigma technologist he can work. If you are having master black belt, you can resign your regular job, whatever you are having, and you can take this as a consultant. Consultants also earn a lot of money. Okay, the second one is black belt. These black belt people, they are the leaders of the projects which are solving the problems. See, they also give training and coaching to the teams. So these are the people who are leading the projects in the companies. Whereas in green belt, these green belts use Six Sigma methodology and statistical tools for solving quality related problems. And also they assist in data collection and analysis for the black belts. See, these green belts are the people actually who are working. These black belts are the leaders of the projects, and under them these green belts will be actually working for the Six Sigma. Okay, then we have yellow belts. These yellow belts are they are participants in the team, in the project team, and they review improvements of processes, and they support the project. They may give feedback and other things, these yellow belts. And these white belts, they only have knowledge and awareness about Six Sigma. They may work for the team or they may not work for the team. Okay, but anyway, because they are aware, they will be able to support in the overall project, but they may not be actively involved in the Six Sigma. So such people are white belt. Okay, so this is how the certification of Six Sigma professionals is. Okay, so okay friends, today we will stop here, and we will continue in the next lecture. Thank you.